All right. So for our next speaker, I guess I'll tell a little story first. And so one day I was reverse engineering this piece of malware, and it broke my Hexrace editor. So I feel the pain that our next speaker is going to be going through. Not really. I couldn't reverse engineer like a Hello World program, but let alone malware. But this guy, John Erickson, has. And I think he has a very interesting story that he's going to tell us. I just hope he can do it within 15 minutes. John.
Thank you. Good evening, everyone. I think for the judges that I should get +1 point for having to go after that talk, because that was amazing. So this is stack cleaning, and if you're playing along with a drinking game, you can take a drink every time I say stack cleaning. Judges, you might not want to do this. This is a quest in hunting for flirt. That's my Twitter handle, that long number there. I'm a senior staff reverse engineer at FireEye on the Flare team. I used to be at Eyesight Partners for 5 years, the MITRE Corporation for 5 years, worked at Lockheed and the U.S. Air Force. So this is a very short talk, so I don't feel like I need to spoil what I'm going to be talking about, but I'll give you a little overview, a little motivation, and then you'll just see what happens. So this is stack cleaning. Now, I realize that everyone in the audience might not be so familiar with x86 disassembly. This is what it looks like, and this is what stack cleaning looks like. So I'll kind of walk through what this means. The top instruction is setting a loop counter to 10. Then the code will flow into the middle block, and it will repeat this action 10 times. Inside this middle block, it's going to allocate 4 bytes of stack space each time it goes through this loop, and it's going to clear out whatever was there before with a null value. It's going to repeat this, in this case, 10 times. Now, typically, when functions are executed at the beginning, they allocate stack space for local variables. This typically looks like something on the left-hand side of the screen, which is a subtraction from the ESP register, in this case by the hex value 28. What happens is the stack pointer moves up, if we view it that way, and what it's currently pointed to in that space is uninitialized or unknown data exists in that slot. Stack cleaning on the right-hand side of the screen, when it's going through this loop, is going to allocate the same amount of space, doing one slot at a time and initializing a 0 in each space as it goes along. So this is what's called stack cleaning. So my motivation is, because of this, you get this error message in IDA Pro that says decompiler failure. I use Hexrace as a crutch all the time. I look at hundreds of malware samples every year. That's not a joke. Like, I probably looked at 10 today. What happens here is this error message is telling you that it couldn't calculate what the stack pointer should be. IDA Pro isn't smart enough to realize that this loop here is going to happen 10 times. It just assumes that that middle block is going to happen 1 time. So it thinks the stack pointer should be 4 versus 28 or something like that. So if you ever do get some type of decompilation error like this, you can actually fix it up in IDA. To do that, you can go into the options menu, and you have to actually enable the stack pointer option by checking that box I'm showing on the left-hand side of the screen. Once you have that option enabled, then going back into your disassembly view, you can right-click anywhere within the disassembly, and you can say change stack pointer. In this case, we can change it to a 4 to, say, 28. Once you've done that, you can hit tab or refresh and go right back into your decompiler, and it'll look great. And you won't run into the problems that you have. Now, some additional motivation. I first ran into this November 2016 in the wild. I drew up on the whiteboard to show my coworker, walked through it, kind of talked about it, and discussed the Hexrace decompiler problem and how to fix it. It was kind of annoying at the time. I didn't think much after that ticket. I just closed it off and moved on with my life. Then I think it was 3-4 months later, I encountered a different malware family, and it also had this same bit of code. And I remembered, I've been bit by this before. It broke my decompiler. What was the other malware family? Now I've got two different malware families, both doing something that breaks my decompiler. It made me angry and obsessed. And I spent the next 2 weeks constantly thinking about this and doing what I'm about to tell you what I did. So, some additional context for you guys. When you bring one of these files into Art of Pro, it tells you that the import section has been destroyed somehow. It's an indication this file is packed or somehow been modified to mess with you. Also has a weird entry point. The entry point I'm showing here on the bottom right-hand side of the screen, I'm saying it's weird because it's not typical. It doesn't look like a normal Microsoft Visual Studio compiled binary entry point. It's not a GCC compiled entry point. It's something I hadn't seen before. So I'm calling it weird. So is this some type of obscure packer that I'm not familiar with, or some other architecture, or other compiler? I'm not sure. I'll use a tool like PID. And in the bottom left-hand side of the screen, I don't know if you can see it, it says nothing found. So I need to figure this out on my own. What is this code? Is this some new obfuscator, some new packer that malware is kind of shifting to? Maybe this is something that we should start researching. So here's my quest. What code produces pattern? What code produces stack cleaning? So I started doing a survey on different functions, read lots of blogs, looked at different products, trying to figure out what could potentially produce this. I looked at, say, alloca function. It does allocate space on the stack. However, it doesn't initialize it to 0, so that's not useful. The B0 memset, they just zero memory. They don't actually allocate memory, so that's not helpful. The heap alloc function allocates memory. It can zero memory, but it's on the heap. It's not on the stack. And it's also not inlined, like I showed with the stack cleaning code. Drink. Malloc, also on the heap, not inlined, not initialized. So what is this? So what I can do is I can say, well, what files have this pattern? I'm going to make a Yara signature, a Yara rule to go look for this. I can take that stack cleaning code that I showed you in IDA with those instructions, and I can take the associated opcode bytes, the machine code bytes, and make a Yara rule out of those. And I can search for that pattern. My Windows directory, no files have that pattern. Program files, nothing. System32, sysfile64, nothing. So I have an idea at this point. I want to go hunt for additional samples on VirusTotal. But I don't want to look for malicious samples. I want to look for non-malicious good samples where I could potentially find source code. So I can go look at that source code, go look at that function to figure out what produced this stack cleaning code. So my criteria for VirusTotal is I want to see files which contain stack cleaning code, so that Yara rule that I just showed you. I want to find files which contain a PDB string. For those of you not familiar, PDB stands for Program Database. It's the location on disk to where the project existed for the developer. So it would be, say, C:users John cool web server XYZ / something.pdb. Now, if I can find files that have both these criterias, then I can look at that PDB string, take that server name, that project name, then go to GitHub and search for that project. Maybe I'll find the source code. In 5 minutes, I had 100 hits, all the same malware family, not very useful. Quickly stop this rule from running. Part 2, we can add an additional constraint. We can say, I want the same stuff I had before, but now I want to see files with less than 5 detections. I probably should have done that before. I want non-malicious files in this case. Now, instead of in 5 minutes, now over 6 days, I had 35 hits. I looked at each of those 35 hits. I looked at all their PDB strings. I went on GitHub. I searched Google, everywhere. I wasn't able to find source code for any of those projects. However, one file which I've listed here, flyLiveinstaller.exe, had 0 detections on VirusTotal. It was a .NET file which contained 7 resources. One of the resources was a native PE executable, and it contained stack cleaning code. And an additional text resource called uninstall L. The total contents of that text resource was English language file for InstallForge. That's interesting. What's InstallForge? So I went and downloaded the InstallForge trial application, which I'm showing here on the screen. I made a simple Hello World application. I went to this InstallForge GUI. I added my Hello World application, and I hit build. And for those of you that are not familiar with InstallForge, it's similar to Install Shield or some type of program that's just used for dropping files, starting a new program on your computer, or installing a new program on your computer. When I hit build in InstallForge, the resulting executable has stack cleaning code, shows imports are destroyed in IDA-Pro, and has those same entry point similarities. That's interesting. But why does InstallForge produce stack cleaning code? That doesn't really help me. It's not really showing me what code produced it. It's a product produced it. So if you run strings on the InstallForge executable itself, you find these series of full paths, and they all end with a .pb or .pbi extension. Do a quick Google search of what is .pb. It's something called Pure Basic, language that I haven't programmed in before. So Pure Basic, I went and downloaded the Pure Basic compiler, and I ended up writing this bit of code here, a procedure called test function. In the test function, I've got 8 local variables, F1 through F8, which I've labeled 1 string, 2 string, 3 string, up to 8 string. And I simply just call this function in my main body. Now, when I compile this Pure Basic code, I find that it has stack cleaning in it. I find that imports show up as destroyed in IDA-Pro, and it has the same entry point similarities. So at this point, we know that the Pure Basic compiler is what is producing this entry point. We know that the Pure Basic compiler creates the stack cleaning paradigm. 3 minutes? I'll try to think how many slides do I have left. Can I fill that or not? And I also found that I have 8 local variables in this case. If I had 1 local variable, it wouldn't produce stack cleaning code. If I had 2 local variables, it wouldn't produce stack cleaning code. It was when I think it went over 4 or 5 local variables, then the compiler thought, oh, I should make a loop out of this versus just pushing 0 onto the stack to allocate space. Mission complete. If you wanted to look for Pure Basic, this is an example of 2 different entry points from 2 different samples. You can see that they're the same as far as the functions they call, memset, get module handle, heap create, the same number of arguments. Some things would be different, such as the sizes and locations to global variables, which you can mask out. I'm not going to explain this pattern, but I've got some question marks for those masked out areas. Okay. Within the Pure Basic compiler directory, there's a series of lib files. These lib files are statically compiled C code that will be linked into a Pure Basic compiled binary, such as objectmanager.lib, string manager, string utility, system base, etc. We can use these lib files and create an IDA flirt database. So when you do that, when you've got the top screenshot is showing you IDA-Pro without flirt, and these blue boxes in this navigation is showing you that this is data and code that you need to be concerned about as a reverse engineer. But when we apply our flirt database that we just created, now we've got this big teal area, which has been identified as Pure Basic library code, and we do not need to be concerned about that as a reverse engineer, and it's less that we need to worry about. That's all, and maybe I have 30 seconds for a question. The question was, why do I think that they're doing stack cleaning? I think it's because it's kind of like a managed, safe language where they will just clear out uninitialized data so you don't need to worry about that as a programmer. Question in the back? The question was, why do I think so much malware is written in this language? I don't think so much malware is written in this language. I think a lot of people use InstallForge as a tool, and that's why I saw so many hits when I did my PT search.
Oh, we're doing me first. Okay. So, John, before you started the talk, you mentioned a drinking game, and then you instructed the judges not to participate. So, -1, rule number 1, you're not the boss of me or my liver. Okay. So now you're all instructed to not tell me what to do. Okay. But you got a +2 because assembly language in a fire talk, whoop, whoop, right? However, you got a -1. What is this, recon? Seriously. However, you got a +3 because with your slide when you were talking about fixing hex-raised disassembler, there is an often lamentable disconnect between debugger, decompiler, disassembly tools. So I appreciate the fact that you were tackling that problem. That's been a long-standing problem in reverse engineering. I appreciate that. So if you've been following along with my steady and consistent rubric that I've applied consistently this entire time, it's a +5 and a -2 for a total of 3. However, you did get a bonus point from me because the background of my phone is Lady Ada Lovelace from the Ida Pro disassembler, and so you just got a personal +1 for that. So thank you. Thank you very much.
So I really appreciated you taking us
four. Total score of 4. Total score of 4. Yes. Yes.
So I really appreciated you taking us on the journey with you. I thought the level of detail that you provided was helpful, and the audience, I know, really appreciated it. I know I did. It's been a while since I've looked at stuff like this, so it was really good. Thank you very much. I think the kind of the punchline at the end would be something to kind of work on to hit your story home. But I think you did a really good job. Thanks.
All right. So as you know, I'm really not a I'm technical, but I'm not that technical. So up front was a little, like I was kind of getting lost. I was daydreaming some. So a little -1, but that's like my fault. So it's really -1 on me, but that counts against you. So because one of the key points in presenting is to know your audience. Did you research me? Do you know anything about me? No. Okay. Probably not. He's like, who the hell is this guy? Who the hell is this guy? Anyway. Oh, really? Okay. But about halfway through the talk, you started telling your story, and I loved it. And I followed it all the way through, and it was just awesome. So I gave you +2 points for that. I'm following your point thing here, so. I love the story again, so that's another +2 points. But beyond the intro material, which I know was probably, like I said, a necessary evil, I thought it was just a fascinating talk, and so a +1. So if you're counting, that's about, +4. So, plus or -4. I love that. All right. So thank you, John.